You hear my audio? Is this hearable? I just want to check the audio and make sure you guys can hear me. All right, so audio, thanks Trent, appreciate it. Okay, you're asking the composition thing. Let me give you an example here. So this would be an example. And the only thing when I talk about this iteratively, I just mean like, you know, what is this equal to? And then part B will say like, what happens if you do the third composition? What is that going to equal? And that's about it. I'm not going to have you generalize it on the exam. You just have to be able to do this, right? So like if I want to find f composite f at x, that's going to be f at x, right? Is f acting on 2x plus 1? Just something like this. Basic stuff here. You get 4x plus 3. And then for like b, it'd be f composite f acting on f at x. Just if I should ask something like that, that's all I was getting at. We know that this is equal to 4x plus 3. So this is 2 times 4x plus 3 plus 1. So I'm getting 8x plus 7. What do you mean? I'm saying you're not going to have to generalize it. We in class we generalized it. Like I'd ask for the nth composition or the 101th composition, something like that. It'll just be take the composition of like f composite f composite f. That's something like that. Is there a method to determine on what end would a rational function approach from a vertical asymptote? So if I go down the asymptote on one end. Well, we talked about this briefly, Abdullah, but like I just had you sum in numbers. But essentially it works just like the the multiplicities. Like if you have, Alexis, this answer your question? Like if, yep. Like if I have something like this, Abdullah, and I don't know the lag for you guys, but like I've now written a rational function on my screen. I'm not sure if you guys can see it yet. You cannot. You must not. Oh. This one here, Abdullah, because the multiplicity on this is even, it really works like you have a vertical asymptote here at 1. And what's going to happen is as I approach it from the right or left, it's going to be positive. It's going to like approach it this way for what I've drawn here. Right? That's because the multiplicity is even. But we didn't really talk about that, or I didn't really make a big point of it. But you can just sub in numbers. Like you could pick numbers to the right and left of x equals 1. Your suspicions were correct. Right, so this will look, and then the y-intercept here is 1, so it looks something like this. I'd have to think about that for a slant asymptote, because you're not really approaching from the left or right a slant asymptote, so that's a little bit different. I'd have to think. I don't think so. I think that's a little different. Anything particular that's on the outline you guys would like me to talk about, or any questions I can go through? I have the textbooks here. Or I can just go through like specific questions. Sir, for compound interest or continuous questions, are we going to have a formula given on? No, you'll need to know the formulas for those. You're not going to be given the formulas for compound interest. So like you'll have to know both those formulas, Kevin. So for compound interest, you have your A is P naught 1 plus R to the NT, where R is like your rate of interest, your like annual rate of interest divided by the number of compounding periods. And then the other one is your continuous growth, which will look like this. So you have to know both of those for the exam, like the formulas on your own. Oh, yeah, Alexis, for that, it just means something like this. Like, let's say I give you like x cubed, x minus 2 to the 5th, x plus 3 to the 4th, let's say. Let's say you get something like that. This would have a root, like your first root is 0, has a multiplicity of 3. Your second root is 2, has a multiplicity of 5. And your third root is a minus 3 with the multiplicity of 4. And as you know, when you add up your multiplicities, right, 9, 10, 11, 12, that equals the degree of your polynomial. Jack, there's no floor or ceiling on the exam. Sure thing. There's a question I actually wanted to make sure you guys know. Okay, 169. Just give me 1 second here. Okay, there's a question I want to go through. I'm not sure if there's enough asked in the homework to prepare for the exam, so I'll go through one of those. But I am wants page what was you on? 314? Oh no, 499. Do 3 and 14, page 499. Oh, that's algebra and trig, right? Oh, sorry. Okay, that's algebra and trig book? Yeah. Okay. So this is our algebra and trig book. This is number 3. Oh no, 14. Sorry, just 14. Page 499. So when you're solving these, Compound interest questions. Will compound interest questions just require subbing values in the formula? Are there any other formulas of that nature on the exam? You just need to know. I said compound interest and continuous interest, and then also your growth and decay models as well was another one I had mentioned. Okay, so with this one here, you want to solve this trig equation. Looking at this, there's nothing to factor out, right? Like I've got this sine of 4x, sine of 2x. I don't have anything to factor out, but I know that the sine of 2x in general is 2 sine x cos x. So I know the sine of 4x is going to be 2 sine 2x cos 2x. So I can substitute that sine of 4x with 2 sine 2x cos 2x. So this becomes 2 sine 2x cos 2x plus 2 sine of 2x is 0. So now you can go ahead and GCF out a common factor. There's a common factor of 2 sine 2x here and here. So I can factor that out. So this is 2 sine 2x times the cos of 2x plus 1 is 0. So now you have the product of two expressions is 0. So the only way that's going to happen, either the sine of 2x is 0 or the cos of 2x is minus 1. Those are like our two options here. Okay, are you with me so far, I am? So you end up getting like sine of 2x is going to be 0 at 0 and pi. So if when you take your sine inverse of both sides, you're going to get 2x is 0 or pi, which means x is 0 or pi over 2. As we discussed in class, the period of your sine 2x function has a period of pi. So you keep adding this period of pi to this, add pi to this, right? And I think the question caps you less than, if I recall, I think in this question the domain is from like 0 to 2 pi, like this. So I can't do any more here with this side. Sorry, Wahab? Yeah, sine is the y value. What do you mean? Yep, yeah, it's the same, Abdullah. I thought you were saying, like, asking me would I be explicitly asking, financial related questions, and the answer is no. So I rephrase it with growth and decay. Are you good so far? No, that's for you're thinking of cos, right? If you go to your unit circle, right, cos theta, sine theta, right? Your sine function is 0 right here. Right, Wahab? The sine of 0 degrees is 0. Cos of 0 degrees is 1. Remember this? And then here, the sine of 90 degrees is 1. Yeah, it's okay. Cos of 90 degrees is 0. So anyways, the other value is going to be here when theta is pi. So you get 2x is going to equal pi, or x is, we get our pi over 2 again to get this negative 1 here. That's when the cos of 2x is negative 1, is just when theta is pi. So in this case, x is pi over 2. The period is still pi, so you're going to add that, and you're going to get 3 pi over 2, which is the same points. So I'm just getting these values here for my answer. I am. For sorry, I want to make sure I'm doing the questions in order. Okay, are you good? Okay, good. And Alexa, you're asking about complex numbers. Just be able to, like, can you solve this? Do you know if I give you something like this, are you able to find the roots? Just the basic complex roots on something like this, or maybe something like this. We can do those. Right, if I want the roots for this is x squared equals negative 4. And then we can take the square root here. Oops, sorry. Take the square root. You remember this? So then x is going to be just real basic, nothing like heavies. That would be as much as you'll see for mine. Right, remember this? So this is plus or minus 2i. That I don't know, Abdullah. I'm not sure. I'm fairly certain no. I think this is the only two intervals that I have you get at. Alexa, is that ringing a bell? Like you're remembering this? So just like super basic equations to solve. Yeah, complex numbers do come in pairs. This is true. Okay, yeah. Yeah. I mean, nothing else. Just complex numbers come in pairs. So like, if I give you something like this, remember we talked about this has either 6 real roots, or it has 4 real roots and 2 complex roots, or 2 real roots and 4 complex roots, or all complex roots. Basic stuff like that. For logarithm equations, why do we need to substitute our answers back into the original equation? When do we introduce the possibilities of faulty answers? So Abdullah, what happens is when you do your logarithmic properties, you're changing the domain of the logarithm when you apply those properties sometimes. So you have to check it in the original. Like an easy example to see that would be like, like the log of x squared. Right, if I give you the log of x squared, right, this has a domain, like the domain of this function is going to be all real numbers, kicking out 0, right? But if you apply your logarithmic property, you can drop that 2 down, and now the domain of this is all real numbers such that x is greater than 0. So when you apply your logarithmic properties, like sometimes your domain can change. So you have to like check it in the original to make sure. Make sense? Yeah, they're not exactly equal. They're equal under like a different domain. Domain changes. So you end up getting more solutions, and then you got to check in the original to make sure that they satisfy the original. Yeah, Trent gave it to you there, Mahir, but I can help you here as well. If the degree of the polynomial is 5, our options are 5 real roots, or you can have 2 complex roots and 3 real roots, or you can have 4 complex roots and 1 real root, and that is it. There's no other options. So, we had discussed this before, but if you have a polynomial of odd degree, it has at least 1 real root. No matter what you do, you're going to have at least 1 real root, so it's going to cross the x-axis. The domain of your original equation, Abdullah, is always larger than the domain of your equation after your properties are applied. So you'll always have how do we sketch a polynomial given particular characteristics? Oh, here, let me think of one. I don't know. Let's say you have an even polynomial. Maybe it has a root at x equals -3. And maybe the leading coefficient is negative, for instance. Would you know how to solve that or sketch that? Yeah, so you have a polynomial of even degree. So if you did a sketch of this, the idea here is that it has a root at -3, but because it's even, then it has to have a root at 3 as well, right? Because they're symmetric, like even functions are symmetric on the y-axis. Right? Even functions are symmetric on the y-axis. They say the leading coefficient's negative. they say the leading coefficient is negative, so that means that it's going to be tending downwards. Now they don't tell us the y-intercept here, but maybe it looks something like this. I'm not really sure, but you could do something like that. Would be a sketch. They might give you maybe get some more information. You can find more about it, but that'd be a rough idea. The main thing is this: you have symmetry, and it actually tells you, if you know one root, you know another one from there. Yeah, give me a second here. From our textbook, you could try page 138, number like 10 and 11. You know, 12 maybe. Like that sort of section has a couple to practice. I wanted to cover a question here. Let me say let me just make one of these up here, or grab one of these, I should say. 2x cubed minus mx squared. We did this on our test. So when this polynomial is divided by like x plus 1, the remainder is negative 12, and by x, and x minus 2 is a factor. That's one we should try out. I'll let you guys try it yourselves if you like. Right? You guys remember this one? When this is divided by x plus 1, we have a remainder of negative 12. And x minus 2 is a factor. Find the values of m and n. Another one, a comparable one to practice, is like page... We did this on our test and covered it a bunch of times, but page 177... number 10 with this system. No, sorry, can't do that, Abdullah. But is everyone good with this one? Do you want me to take it up? And if you're looking to practice that style, like because Alexis was asking that sort of question, there's like another problem here, page 177, number 10 is a similar style. I'll take this one up. So they tell you you have this degree 3 polynomial. They tell you that x plus 1, when it's divided by x plus 1, it has a remainder of negative 12. So that means that the polynomial, this is your remainder theorem, the polynomial evaluated at negative 1 is negative 12. Like, I know that. And the second piece of information I know is x minus 2 is a factor. That means the polynomial at 2 is 0. So this generates two equations. One equation is negative 12 is going to be negative 2 minus m minus n minus 2. That's one of my equations. And my second equation is the polynomial at 2, so that's going to be is equal to 0. So 0 equals, if I sub a 2 into here, that'll be what, 16 minus 4m plus 2n minus 2. And then you have like two equations, two unknowns to solve. So if you want more practice, there's another one here like that. But this is going to be, what does that come out to be? M plus n is equal to negative 4 plus 12. So we get 8. And then the second equation is going to be what? 4m minus 2n is 14. And then you're solving two equations, two unknowns to solve this. So I think this is correct here. Is my math right here? If I sub this in to here, you're going to get 2 to the 4th is 16 minus 4m plus 2n minus 2. Okay, that's good. Brought this over and cleaned that up. Then brought that over and cleaned that up. Okay. So then you solve two equations, two unknowns. So I'm going to multiply equation 1 by 2. 2m plus 2n is 16. And equation 2 is 4m minus 2n is 14. You can add these together here, to which I get 6m is 30, or m is 5 for this one. And if m is 5, then n must be 3. So those are your m and n values for these. Good. I can't say, Abdul, like, I don't know what your definition of sufficiently prepared means. I think you'll be fine. 50% at a minimum. Are there any other questions, guys, you got? Anything else I could help you guys with? Are we good? Page 308, number 13B. So for 13B here, they're asking for the instantaneous rate of change at 3 is what they're asking for 13B. Abdullah, for your question there, yeah, you can use another definition not taught in class as long as it's correct. That's fine. Well, you can't quote calculus in a pre-calculus class. That's cheating. For your question here, they give you the function is 5t over t squared plus 7. 5t over t squared plus 7. And for 5b, they want you to find the instantaneous rate of change at 3. So the equation that we had talked about for instantaneous rate of change was this one. Since the t value is 3, it's really f at 3 plus h minus f at 3 over h. Remember this? So I had suggested for our pre-calculus class, let h be very small, maybe 0.001. So we're really evaluating, we're really evaluating the function at 3.001 minus the function at 3 divided by 0.001. So we just got to calculate that. So let's check it out and see. And you can check my math on this as well. I'm getting approximately 0.93746 minus the function at 3 is just 15 divided by 16. So I'm getting IM approximately negative 0.04. This is my answer. Yeah, they mean to use instantaneous because it says the word estimate. So they're saying the instantaneous rate of change at 3. Sure, I got to do Hyatt's question here. What's that one there? Where'd you get this one? 3. Oh, you don't have to worry about factoring multivariable functions on the exam. So not to worry about that one, Hyatt. Okay, very good. All right. Mahir's looking for page 377. 19C and D. 19C and D. You know what, Mahir? Your issue, I bet, was you're calculating radians or degrees? Because they're using radian measure here. I bet your calculator when you did it was in degrees. Because the calculation is just P at, you're going to do P at 0.3 minus p at 0.2 over 0.3 minus 0.2. Yeah. They have an 8 pi over 3, so I'm assuming that's in degrees, or radian measure. So that's, you probably had your calculator in degrees. I only know because I think Yusria had asked it. Is Yusria there today? Oh no, that's period 3. You guys are period 1. Okay, here we go. Sure. Okay, so I'm gonna have to calculate these individually here. Let's try it out. P at 0.3. Make sure I'm in radian measure. So I'm getting that value for P at 0.3, P at 0.2. Get that. So plug it all in here. Do you happen to have an answer to me here? Oh, I can look. This is 177.19C. Okay, yeah, I got 140.89 for my C value. That's C. Yeah, so it was in radian measure. Do you want me to go through D here? Okay. Yeah, you would just do this formula. And let H be something like, fairly small value. You'll see this tomorrow on the exam, I'm sure. Okay, so C and D are done. Hyatt, could we look at this one here? Oh, you're going through old test questions, I see. Is Dia and Kinlon, are you here? You had said you'd be here. Just curious. Is Lauren here? Lauren said Lauren be logging on here. Who else is in my period 1 class? Oh no. Oh, Leanne is here. Oh, Lauren's here. Dia's here. Can anyone tell me who Hyatt Adam is? Because I don't know who this person is. I've been trying to find out for like the last 7 streams, but this person has not told me their identity. I'm wondering who this is. Yes. Maybe. But this person has all our test questions. I'm not sure. All right. Okay, so they give you this polynomial here. Not the mystery. Anne has all the tests, has all their homework, so it must be someone in our class. Elusive. One day we'll find out. Okay, so mystery person, for this question here, the idea here is if you do a substitution and let t be x minus 2. Okay. If only that wasn't coming from me here, I might believe it, but you have ulterior motives. So if you let t be x minus 2, you got yourself a degree 3 polynomial. And then you can go ahead and break this down using synthetic division. In fact, if I let t be -1, you'll notice here you get 4, 0. Don't forget when you're doing synthetic division, if there's not like a t squared in that spot, you have to put a 0 in that location. That'll really mess up your stuff for your exam tomorrow if you're doing synthetic division. And if you go through synthetic division here, bingo, we get 0. So that becomes a root. So my polynomial p at t is going to factor into t plus 1 times 4t squared minus 4t minus 3. Good so far? Hyatt Adam. Is this good? Yep. Okay. So once you get a quadratic, then you're good. You can factor this, right? So I can do some charting on this and break this down. This polynomial here, like 4 and 1, 1 and 4. Or you can do decomposition. I know some of you guys like decomposition. And I got to get a match here. It comes out to -4. Boom, these two. So this will, I guess we're not done yet. Sure, just a second here. So this becomes t plus 1, 2t minus 3, and 2t plus 1. So the answers I'm getting here are t equals -1, 3/2, and -1/2. But it's not a t that we want to solve for. We want to solve for an x, but I let t be x minus 2. So therefore I have x minus 2 is -1. Good question. Was this one of my test questions? It's a good question. So I'm getting then x is 3/2 plus 2 is 7/2. And lastly, x is 2 minus 1/2 is 3/2. So these become the three answers for this one. Okay, here was asking for like an example of a piecewise function where you create the piecewise. Like I give you the graph. Sure. Do something like this. I just have to add some more information, else you can't answer it. Maybe this is -4. Maybe we know this point here is the point 3 -4, let's say. And let's say this point here is 7, 0. Me? I bought one of those like you know how they have there's like used to have this thing called the Doppler 4000. I bought one on eBay. I put it on my roof. It says that there is no snow day tomorrow. Yeah, Doppler 4000. I can't remember. Maybe 5000. What did I change? Something's being changed on Edsby? Yeah, guys, I would guess the best bet would be at 6 a.m. Go to go to Greater Essex County front, website, and it'll be in red at the top. It'll say go to write your exam, don't write your exam. It'll go to bed. It'll say or write your exam. Okay. So here's one you can try. Do you want me to do this one, or what's going on here? So Mihir was asking for an example of a piecewise function that's graphed for you, and they want the equation. So, if you were to do this one, you start from left to right. If something like this were to be asked on the exam, it would be like simple, like a simple version of it. And like I would kind of say this is pretty simple. Guys, just in the morning, go to the Greater Essex, go to the site. You'll see it. It'll be good. No big deal. Right at the top, Alexa, tomorrow it'll say in red on our school board website. It'll tell you what to do. So for this question here, they want you to graph this following piecewise function. It's a flat line here. Now, sorry guys, you need more information because we want to know what the height of this is. I'd have to give you maybe one of these points. So let's let this point be -3 and 2, let's say. So I didn't give you enough information. So this piecewise function here, how is it defined? Well, you've got yourself a flat line at y equals 2, and that continues on as long as x is, now notice this is a solid dot here, so it's going to be x is less than or equal to -3. When x is less than or equal to -3, it gives you a solid line at 2. As soon as x is greater than -3, it kicks in and becomes another flat line, but that flat line changes to -4. So in this example here, we have a flat line at -4, and that'll continue on all the way up until we hit 3. But notice there's a solid dot here at the 3. So I can include the 3. I can put equality there. You guys see the difference? I've got equality here, do not have it here. There's a hole here. We do not include it. Solid dot here, we include it. Good. And then it turns into a linear equation, so you kind of have to calculate your slope for this question. So the slope will be the change in your change in your y over change in your x, in which case the slope here is 4 over 4 is 1. So the equation of this line is y is x plus b, and you can sub in any point you want here. I can sub in this point or this point and find the equation. If I sub in 7, 0, it's going to be 0 equals 7 plus b, and b is -7. So the equation of this line is x minus 7. And that's going to go when x is greater than 3 all the way up to infinity, because you have that arrow going on. So I can just write it as x is greater than 3. And you would have, this is an example of finding the equation. No, I don't think we did, Abdullah. Turning points are pretty minimal on my exam. Question with quadratics. Quadratic, eh? Yeah, I can't think of a clean one off the top that would I could do. Suffice it to say, Wahab, you don't have to know it. Wow, Abdul, that's pretty funny. I'm gonna use that joke. Very funny, very funny. Okay, so anything else? Well, true, true. It wasn't like funny, like hilarious. It wasn't like the bed sheet joke I made. It wasn't that caliber of funny, but still funny. Funny smile, not funny haha. Hyatt? I don't. Hyatt. Oh, you know what? I bet Hyatt is Kinlon. Is Hyatt Kinlon? Maybe Hyatt is Kinlon. Oh. Sure you are. Sure you are. As if you would tell the truth. And yet. Okay, so. Oh, there's some questions up here. What's going on? I am want some page 6A on page. Number 6A on page 440, sure. Six A. All right. Page 440, 6A. Sine of x is 3/5. Sine of x is 3/5. X is acute, and find all this stuff here. So in this question here, they tell you that you're like x is an acute angle. So it's another way of telling you that you're in your first quadrant. So I've kind of like I'm here. Right, because sine is positive, so it could have been in this quadrant as well, but then x would be an obtuse angle. So I know it's acute, so this is opposite over hypotenuse, and then you can, using Pythagorean theorem or just your 3, 4, 5 identity, you can see that that leg of the triangle is 4. So in this case here, you just, from here, if you want to find everything, the sine of 2x is going to be 2 sine x cos x. Yep. Yeah, I figured. And then you sub it all in. And we're good. All right. Am I missing something here? Hyatt said they'd asked a question above. I don't see a question. Could you run through a rational inequality problem? Sure. You want to try this one? Page 440, what did you want to see on it? Oh, in this example here, the thing is they tell you that the sine of x is 3/5, but sine is positive in both this quadrant and this quadrant. So like, which one are they talking about? Well, in the question they say that x is an acute angle. Acute angle is an angle that's less than 90 degrees. Right? So like if they say an acute angle, it's less than 90 degrees. So the idea here is that therefore the triangle they're referencing must be an acute angle triangle, not an obtuse one. Yep. So I knew what quadrant it was in, so I know like cos is positive in this quadrant. I made this question up. This is just a rational inequality, but Abdullah was asking about it. So if you want to solve it, you just kind of bring everything to one side. Right? You always, when you're solving your rational inequalities, always bring everything to one side. That's always going to be your first step. Then you're almost every time going to get yourself a common denominator here. Right? And then you're going to clean it up. Now, I made this question up, so it's like a little... Oh, it's not too bad. Right, so I can kind of factor this up. I can factor in a negative x. I get x minus 3 over 5 times x plus 2 is greater than 0. So this is my inequality here. Right, so we can solve this now. So you draw your number line. Right, so the process is, just to review, bring everything to one side, get a common denominator, clean it up, then identify values where your rational function is 0 or undefined. So those values are going to be 0, 3, and negative 2. Kind of plot these, 0, negative 2, 0, 3. I'm going to put open circle at the negative 2, and then at 0 and 3, we have solid dots there. But let me just, we're going to have not including those for different reasons, but we'll get to that. So once you identify that, then you just pick a number within each interval. So I pick something greater than 3, like 100, and sub it in. You're going to get a positive value here. This will be negative when you multiply by the minus sign in front. This will be positive. So the resulting product will be negative. So it'll be a negative number. Negative numbers in this interval. And then when you pick a number between 0 and 3, it's going to be positive. If you were sub something in, between negative 2 and 0, it'll be negative. And then less than minus 2, it'll be positive. And Abdullah, here you'll also notice that it oscillates back and forth because the powers on each of these roots and spots are odd. Right? And I'm interested in knowing when is this greater than 0. So that's going to be, that's going to be this interval here and this interval here. So the answer is going to go for my question is negative infinity to negative 2 open bracket, because I don't have negative 2 is undefined there, union 0 to 3. Also open bracket on the 0 and the 3, because this is strictly greater than 0. You don't have to check that on the exam. Like, I mean, you might have a question where like your graph has to finish to graph it has to cross the slant or horizontal asymptote, but you don't have to like check it. So you can graph it as if it crosses or doesn't cross. Doesn't matter. If that answers your question. Sure. Is that x plus 1 like this? Like, is it the whole thing on the bottom, or is it like divided by x plus 1? Okay, so I'm assuming you're saying yes, what I have is right. So if you want to solve this here, you interchange the x and y's. Step 1. Step 2, multiply across by the denominator, like, get rid of the fractions. Step 3, you can distribute your x. Right, I'm looking to solve for y here. So I'm going to bring the y's to one side. Factor that y out. Divide by y. And I get what? X plus 7 over 3 minus x? I'm getting this for the inverse for this one. So far, so good? What's the wow about? Did you get it right? Okay. And Mahir, by proving it, do you mean like Hyatt, if there's I made like a 30-second lesson, I think, of me doing another example. If you're looking to practice another one, in my videos under like shorts, there's one there. Inverse of a function. I did another one like that. Like if you're looking to practice some more. Mahir, what do you mean prove it? Do you mean like verify the inverse property? Like F composite F composite F inverse is equal to Oh, okay, sure. Prove it, eh? Okay, so I've got my function p, and I got the function p inverse at x. So I just want to show this is equal to x. They call that the identity function. So this will be p acting on p inverse. And now everywhere I see an x in this equation, I'm changing it to this thing. So this will be 3 times x plus 7 over 3 minus x minus 7 over x plus 7 over 3 minus x plus 1. And this is 3x plus 21 over 3 minus x minus 7. I'm looking to get x out of this thing. Is x plus 7 plus... So I'm just getting a common denominator here. Kind of messy. But this ends up being here. 3x plus 21 minus 7 times 3 minus x over 3 minus x over, you'll notice here the x's cancel. I get 10 over 3 minus x. A little messy, but the 3 minus x's will cancel. We're almost there. I want this to come up to be x. So on the top I get, what, 3x plus 21 minus 21 plus 7x all over 10. 21's cancel. I get 10x over 10 is x. Wowzers, there we go. And you get your answer. You see that here? It's kind of hard to follow, but I did my substitution. And then you're just doing the algebra to clean it up. You end up getting x. And I mean, like, really, Mahir, you should check it the other way as well. But it'll be the same idea. Like, if you do p inverse composite p, acting on x, you'll also get x as well. And then, you know for sure it's the inverse. Inverses are unique. Okay, anything?